Okay, let's start with exercise 1.2. Exercise 1.2. Now, we have to decide whether the following sets are equal sets and which are not, and we have to justify our statement. Now, first, A is a set of all x such that 3x minus 1 is equal to 2. Right, this is my set. Now first I have to write the set in the listing form. Now see here, this is my working column. Okay, this is my rough working column. Now A is a set of all x such that A is a set of all x such that 3x minus 1 is equal to 2. 3x minus 1 is equal to 2. Okay, so what we do is we go to the working column. 3x minus 1 is equal to 2. Therefore, 3x is equal to 2 plus 1, which is equal to 3. Therefore, x is equal to 3 upon 3. X is equal to 1. Therefore, my set A has the element 1. Okay, set A has the element 1. Now, my B is a set of all x such that x is a natural number. X is a natural number. X is neither prime nor composite. Therefore, B is equal to neither prime nor composite. Therefore, B is equal to 1. Now, C is a set of all x such that x belongs to the set of natural numbers and x is less than 2. Which are the natural numbers less than 2? The natural number less than 2 is 1. So C is equal to 1. Okay. Now you check out, they want to know whether the following sets are equal or no. So my set A has the element 1. Set B also has the element 1 and set C also has the element 1. So therefore, from 1, 2 and 3, we can say that set A is equal to set B is equal to set C, since they contain the same elements. Since they contain the same element. See, everywhere the same element is there, right? The same element 1. Since they contain the same element, we can say that these sets are equal. Okay. Now, next. Okay, let's go to question number 2. Okay. Decide whether set A and B are equal sets. Give reasons for your answer. A equals to even prime numbers. Even prime numbers. Which is your only even prime number? Your only even prime number is 2. Call this as 1. Right? Next, b is equal to all x such that 7x minus 1 is equal to 13. Now we have to solve this equation. Let us go in the rough column and solve it. 7x minus 1 is equal to 13. Therefore, 7x is equal to 13 plus 1, which is equal to 14. Therefore, x is equal to 14 upon 7. X is equal to 2. Therefore, B 2. Okay, this is my equation 2. Right? Now, are these sets equal? Okay, so we have to say set A equal to set B. Okay, since they contain the same elements. Since they contain the same elements. Okay, now see the next question. Question number 3. Question number 3. Let us check out question number 3. Let us check out question number 3. Which of the following are empty sets and why? Which of the following are empty sets and why? A is a set of all x. No, A is a set of all A, I'm telling you, such that A is a natural number A is a natural number less than 0. Now, which are the natural numbers less than 0? Are there any natural numbers less than 0? Okay, no. So, A is an empty set. Okay, so this is an empty set. Since they contain no element. 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 Okay, next one. B is a set of all x such that x square is equal to 0. X square is equal to 0. Now you solve this. X square is equal to 0. Therefore, x is equal to square root of 0. What is square root of 0? Square root of 0 is 0. Therefore, B has the element 0. Okay. Therefore, it is not an empty set. It is not an empty set. Okay, because it contains 0, so therefore it is not an empty set. Okay, now next one. This is sum number 2. Okay, 0 also means there is an element. Okay, now next one. Question number C. C is a set of all x such that 5x minus 2 is equal to 0, and x belongs to the set of natural numbers. X has to belong to the set of natural numbers. Now let's solve it. 5x minus 2 is equal to 0. I'll take this 2 on the other side. I'm doing in listing method. Therefore 5x is equal to 2. Therefore x is equal to 2 upon 5. Now my x is supposed to be a natural number. Is 2 upon 5 a natural number? No. So my C does not contain any elements. This is my third question, third sum, right? Okay, therefore it is an empty set. It is an empty set since it contains no element. If it contains even one element, even if it contains 0, it is not an empty set. Now see question number 4. See question number 4. Okay, no, 3 is the last one. Okay, now let's see Roman numeral 4. What is the question? Write with reasons which of the following sets are finite and which are infinite sets. Now, finite sets means they can be counted. Infinite sets means they cannot be counted. Okay. Now, see the first one. The first one. Okay. A is a set of all x such that x is less than 10. X is a natural number. X is a natural number. Therefore, A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, and it stops at 10. I can count. Okay, therefore, it is a finite. Second sum is, just written the sums out already. B is a set of all y such that y is less than minus 1 and y is an integer. Y is less than minus 1 and y is an integer. Therefore, integers less than minus 1. Okay, they start from whatever, they go on. So it is, I can say dash, 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 minus 3, minus 2, no, they want up less than minus 1. So it stops at minus 2, but this side it can go on. Okay, therefore it is an infinite set. Let's have someone read the next sum. Set of students of class 9 from your school. What type of set? Finite set. Set of people from your village. Finite set. Set of apparatus in the laboratory. Again, it is a finite set because you can count the apparatus in the laboratory. Okay, let's go to the next sum. Okay, I have written all these sums out. Now, next one, set of whole numbers. Whole numbers are starting from 0. Okay, so they go on and on. So what type of set is it? It is an infinite set, right? Set of whole numbers. Okay, I repeated it again, and actually this is natural numbers. Okay, set of natural numbers. Okay, which is also an, this is not whole, it is natural numbers. Okay, make the correction. It is an infinite set. Set of rational numbers once again is infinite set. Now we'll start with exercise 1.3 where I'll teach you two simple things. First is how you do union and the other is how you do intersection. Now union means both the sets together. So you have 1, 2, 3, 4, 5, 6, 7 and 8. This is my union set. And intersection intersection is whatever is common. Are there any elements in common? There are no elements in common. So my intersection set is a null set. Okay, I'll do some more sums of this type, union and intersection set sums, right? Now see here. Second, A is a set of all x such that x is a factor of 12. Okay, next, B is a set of all y such that y is a multiple of 4, but y is less than 40. Now, the first thing I have to do is I have to list the sets. Come on, what is my set A? Factors of 12. 1 is a factor, 2 is a factor, 3 is a factor, 4 is a factor, 6 is a factor, and 12 is a factor of 12. Multiples of 4 less than 40, therefore B is equal to, which are the tables of 4? 4, 8, 12, 16, 20, 24, 28, 32 and 36, less than 40, right? Now I want to find out A union B, and I want to find out A intersection B. Now union B means everything together, so I will write 1, I will write 2, I will write 3, I will write 4, I will write 6, I will not repeat. Now I have 12, but here then I have 8, then I have 12, 16, okay, 16, 20, 24, 28, 32, 36. Okay, now what is A intersection B? A intersection B. Only what is common? What is common in both these sets? 4 is the only element which is common. So this is my A intersection B, right? Okay, now one more sum we will do on union and intersection. One more sum we will do on union and intersection. Okay. Okay. Next one. A is a set of, let us write, X is a set of all X such that 3x minus 2 is equal to 7, and Y is a set of all Y such that Y square is equal to 9. First, let's list the sets. I want to find out union and intersection. This is my X, this is my Y. Now, look here, 3x minus 2 equals to 7. Therefore, 3x is equal to, this minus goes on that side, it becomes plus, 7 plus 2 is 9. Therefore, x is equal to 9 divided by 3, x is equal to 3. Okay, now y square is equal to 9. Therefore, y is equal to square root of 9. What is square root of 9? Square root of 9 is plus 3 as well as minus 3. So, plus 3 is also square root of 9. Minus 3 is also square root of 9. Correct? Now, I want you to find x union y, x intersection y. Union means together. So, plus 3 and minus 3. Intersection is only what is common. What is common? Plus 3 is common. Okay, so these are my sums for union and intersection.